Well, hello guys. We are building and building, and today's topic is called incomplete quadratics. Now, before we dive in, let's just remind ourselves what a quadratic is. A quadratic is in the form of ax squared plus bx plus c. Okay, let's take note that it has three terms. And the main idea is it has this square term, that's what makes it a quadratic. And the shape that it makes, of course, is a parabola. Now, what are incomplete quadratics, you must be asking yourself? Well, basically, let's get this definition down. They are missing one or more of the terms. Basically, they're not complete. They don't have all three terms. One of them is missing. All right, now I've got this crazy idea for you. You haven't seen it before, but I want you to box this in your notebook and get it in there nice and neat. When we, notice that means we, you and me, we take a square root, we actually have two answers. Now you might be thinking, wait a minute, I've taken a square root before, I don't usually get two answers. Well, here's the deal. Let's say x squared equals 36. All right, to get rid of that squared, I'm going to take the square root of both sides. But now I'm going to write plus or minus the square root of 36. So I'm actually going to get x equals plus or minus 6. Now, let's check and see if that's true. What happens if you take 6 and you square it? Do you get 36? Well, yeah, of course, 6 squared is 36. What happens if you take negative 6 and square it? Do you get positive 36? You do. So in fact, when you take a square root, you actually get two answers. This is amazing. Let me just show you again. If I said x squared equals 25, and I take the square root of both sides, make sure you've now put plus or minus, and I get x equals plus or minus 5. And it should make sense because positive 5 squared equals 25, and negative 5 squared equals 25. So there really are two answers. Example 1. Solve each of the following incomplete quadratics for all values of x. If an equation fails to have any real number solutions, state so. So can you see that this first example, A, is incomplete? Remember, the equation is ax squared plus bx plus c. All right, it should have three terms. The squared term, which makes it the quadratic, the term with the x, and the constant term. This one's missing the term with the x. So how do I solve it? Well, my goal is to get that x by itself. So all I would do is add over the 16. All right, so again, I'm getting x alone. And then I'm saying to get rid of a square, I am taking the square root of both sides. Now remember, when I physically put my own square root there, notice how it didn't have a square root, and when I put my own in, I get two answers. The square and the square root cancel out, and I know the square root of 16 is 4, but I actually get plus or minus 4. Okay, and now I can verify that. If I take positive 4 squared minus 16, I get 0. And if I take negative 4 and square it, I get that positive 16 minus 16 equals 0. So remember, you get two answers, and you can list them out separately if you like, or you can just say plus or minus. Example B. Notice it's an incomplete quadratic. It does not have the three terms. Again, it's missing the term with the x. So the one value is already by itself. Now I can't take the square root yet. I have to get that x by itself, so I'm going to divide both sides by 2. So I get x squared equals 25. And then, of course, to get rid of that x squared, I'm going to square root. But when I do that, make sure you write plus or minus. And in fact, I'm going to go back there and put my plus or minus on that one. And I should get x equals plus or minus 5. Well, you think you got the hang of it? Why don't you pause it, try C on your own, think about what you're going to move over first, and see if we get the same thing. Pause it, see what you get. Did you get what I got? Now again, the point of you pausing is not to cheat yourself and practice these. I'm going to add the 8 over, got 20, divide by 5, I got 4, take the square root, and don't forget the plus or minus. All right, I got a few more for you. Now I threw some fractions in there just to mess with us a little bit, but don't let it fool you. So I'm going to move my 7 over. So 2/3 x squared equals 1 minus 7 is negative 6. All right, now watch this trick if you're not familiar with it. If you want to get rid of a fraction, you just simply multiply by the reciprocal. The reciprocal of 2 over 3 is 3 over 2. You see, reciprocal. Let's make sure we're familiar with that word. And I'll do the same thing on this side. Multiply by 3 over 2. Now, remember when you multiply, the 2 on the top and the 2 on the bottom cancel, the 3 on the top and the 3 on the bottom cancel, and I get x squared. Put this negative 6 over 1, and when you multiply the tops of fractions, so that's negative 18, and you multiply the bottoms of fractions over 2. So x squared equals negative 9. Now I'll take my square root, plus or minus. Can I take the square root of a negative right now? No, that's one number I can't do. So I get, let's say, a non-real answer. All right, and that's what you're going to write down. You cannot take the square root of a negative number. So you get a non-real answer. And you'll find more about that in a couple weeks. All right, why don't you pause it? You got E, and see how it goes. All right, now I don't want you to get scared, and I don't want you to grab your calculator. Watch this. Hopefully, you added the 7 and divided by 4. We're going to take the square root of both sides, so those cancel. Don't forget that plus minus. So I get x equals plus or minus. Now, believe it or not, you should be able to do this in your head. Remember, I'm really just taking the square root of the top and the square root of the bottom. Well, the square root of 1 is 1, and the square root of 4 is 2. So your two answers are x equals plus or minus 1/2. So if you have a fraction, just do it to both the top and the bottom. All right, last one here. We're going to subtract 4, so I've got 2/9 x squared equals 18. Now, do you remember that step? How do I get rid of a 2/9? Hopefully you're saying multiply by 9 over 2. That word is reciprocal. Okay, I'm going to put that 18 over 1. 9 on top, 9 on the bottom, 2 on the bottom, 2 on the top. So I get x squared equals, let's see, 9 times 8 is 72, carry the 7, so that's 162 divided by 2. And I'm going to clean that up. X squared equals 81. Take my square root, don't forget my plus minus, and I get x equals plus or minus 9. Alright, our next set of examples are going to have irrational answers. And of course, irrational means something with a radical. Exercise 2. Solve each of these incomplete quadratics for all values of x. Place all answers in simplest radical form. So you have to simplify the radical. Alright, so I'll do the first one with you, and then you try the next two on your own. My first move, hopefully your gut's saying the same, is to add over the 5. So I get 3x squared equals 24. Alright, my goal is to get x by itself, so my next move, hopefully your gut's saying the same thing, divide both sides by 3. And I've got x squared equals 8. Okay, so far so good. To get rid of a square, I'm going to take the square root, but now we're smart now. We know when we take a square root, we actually get two answers, plus and minus. So I've got x equals plus or minus. Now, radical 8 can be simplified, and that's what those directions were stressing. Simplify 8. I need two numbers where one is a perfect square and one is not. So hopefully 4 and 2 jump out of the page at you. And I can say to myself, now notice the order they're in. There's a plus and minus, then this number, then this number. Keep that plus and minus. The square root of 4 turns into the number 2, and then I'm left with a radical 2. All right, so I can't stress this order enough. Okay, it's got to be plus or minus your number outside the radical, then your number in the radical. All right, just in that order. Don't separate these two, they're being multiplied. And it's that simple. So again, you're going to get the most out of this flipped classroom if you literally pause it and try it. And Taylor, I hope you're writing every problem down. All right, B, you've got the next one. All right, so pause it, try it on your own, and then I'll walk you through it. So here's what I've got so far. I subtracted my 1, I got 5, divided by 10, I got 5/10, and I simplified that first. I got 1/2 then. All right, so now I'm going to take my square root. I'm going to square root this side, and when I square root this side, I need a plus and minus. Okay, so I am left with, now I know that looks ugly and you're dying to grab your calculator, but don't. Just write down what you get. I get a plus or minus, I get a radical 1 over a radical 2. Remember, on day 1, we said we could separate when we're dividing and really take the square root of the top and the bottom. Now this one can actually get cleaned up a lot further, especially if it's multiple choice. You wouldn't see that answer on your paper. Watch what we do next. We're going to keep the plus minus, okay? And which one of these do you actually know? Well, I know the square root of 1 because 1 times 1 is 1. And I don't know the square root of 2. Now, unfortunately, that's not going to be the choice either because this fraction is not rationalized. And that's what we talked about the other day. We need to rationalize that fraction. Okay? And what does that mean? Well, it means you can't leave a radical in the denominator. So because it's a monomial, I'm just going to multiply the top and bottom by radical 2. So I get x equals plus or minus 1 radical 2 is just radical 2. And remember, any radical times itself is really just that number. So I get radical 2 over 2. And that, my friends, is my final answer. All right, so let's do it again. Get every note written down, every example, pause it, try the next one on your own. Pause it, see what you get. So you can see my work again. I subtracted the 3 divided by 4 and took my square root. So I've got x equals plus or minus radical 3 over 4. Now I'm not done. Remember, I do know one of those radicals. So I'm going to say this is plus or minus. I don't know the square root of 3, so I'm going to leave it alone. But I do know the square root of 4 is the number 2. Now, is this one rationalized? Well, I would say yes, because I don't have a radical in the denominator. So those are my two answers. Plus or minus radical 3 over 2. Now, I told you in the beginning there's lots of examples tonight, and they're all a little different. So our next two are different again. So to solve each of the following equations for all values of x. So here's my first one. I've got the quantity x minus 2 squared equals 36. All right. So basically, I have to get rid of this square. And to get rid of a square, you take the square root. Just don't forget, you're going to get a plus and a minus now every time you physically put your own square root in there. Okay, now if the square root's already there, we don't put the plus minus, but when we put it in the problem, we put the plus or minus. So, of course, those cancel, and I've got x minus 2 equals plus or minus 6. Now all we're going to do is we're going to stem it off like we did before. I actually have two answers. I have x minus 2 equals 6, and I have x minus 2 equals negative 6. I'm going to solve for x. I add my 2, I get x equals 8. I'm going to add my 2, and I get x equals negative 4. Now lastly, every time I solve an equation, I need to check. All right, that's our big theme this year. So let's take 8 and let's check. Make sure it goes back to the original. 8 minus 2 is 6, and 6 squared is 36. That checks. Let's check negative 4. Negative 4 minus negative 2 is negative 6. Square that, and you get positive 6. So that checks as well. So my two solutions are 8 and negative 4. All right, second example. Now there's only one step that's different. Can you see what it is? Well, I hope so. Basically, we have this 2 in front. All right, now I can't take the square root until this is isolated. So what does your gut tell you to do with that 2? Hopefully you've guessed it, and you're dividing over the 2 first. So now I have x plus 4 squared equals 8. All right, again, pause it and try it on your own. It's exactly what we just did. Pause it, see what you get. All right, you can follow my work again. I took the square root of both sides, put my plus minus on, and I'm going to get my two answers. So on this side, I'm getting, notice I get x plus 4, but now I can break down radical 8. I need to simplify that radical. So I'm going to go with 4 and 2. So I basically get x plus 4 equals 2 radical 2. And I need to subtract the 4. So I'm going to say that's x equals, if I move the 4 over, that becomes a negative 4 plus 2 radical 2. Okay, notice I can't break up the 2 radical 2. They're married, they're multiplied together, so we call that married. And I'm just bringing this 4 over. Likewise, on the same side here, let me get some more room. I'm going to say this is x plus 4 equals, I'm going to break up, oops, that's a negative, radical 4 radical 2. So I get x plus 4 equals negative 2 radical 2. And again, I'm going to subtract that 4 over, so I get x equals negative 4 minus 2 radical 2. Okay, I can't break them up. Like I said, they're married, they're multiplied together. And these aren't like terms, of course, so I can't add them together.
Exercise 4. Consider this quadratic. Using your calculator, create a sketch of this function on the axis to the right.
Use your calculator to find the two zeros of the function and label them on your graph. Round those numbers to the nearest hundredth. Now, why are they telling me to go to the calculator? Well, notice you cannot factor this. So again, I'm just going to go to the calculator and find my table. All right, so I've got my graph. Now here comes the part we practiced a while ago. We need to find the two zeros of our function. Okay, so I want you to highlight these points in your notebook, nice and big. These are called your zeros. Okay, another name for them are roots. Okay, those mean the same thing, zeros and roots. And it says find them to the nearest hundredth. So let me drop those steps down for you again. You're going to go on your calculator, second trace, or calc, I believe the button says. Okay, second trace, and you are looking for the number 2, which says 0. Okay, you're going to move your cursor right to the 0. You're going to stick it right on top here. And then you'll notice in the bottom it says left, and you want to hit the left button so you're clearly on this side, and you hit enter. Then you got to go to the right so you're clearly on this side, hit enter, and take a guess. When I did that the first time, on this side, I got x equals negative 1.16. Okay, you want to make sure you can do this. So take your time and practice it. I'll be there in the morning if you need help, or after school. Then I got to do the same thing on this side. So I got to do the same direction. Second trace, 0. Okay, arrow over so your cursor is as close as you can get to that, and play the game again. Hit the left arrow a few times, hit enter, hit the right arrow a few times, hit enter, and get your value. I get x equals 5.16. Okay, make sure you can get that. Part B says, write the right-hand side of the quadratic in its vertex form by completing the square. So let me jot down that equation again. So this is just a nice little review. X squared minus 4x minus 6. And they want us to solve this for x completing the square. All right, so do you remember how to play the game? You'll look at those two first. Okay, you cut that middle term in half, square it, add it and subtract it. All right, so let's do it together. Take negative 4, cut it in half, you get negative 2. Don't forget it's called completing the square, so now square it. So I'm going to add 4 and I'm going to subtract 4. Remember, the first 3 should be a perfect square trinomial. That's really the quantity x minus 2 squared. Add these two terms together, and I get negative 10. Okay? Now, I want to go one step further and actually solve this equation. So, let's set this equation equal to 0. So I'm going to say x minus 2 squared equals 10 when I add that over. I'm going to get rid of the squared by taking the square root. Don't forget your plus or minus. So I get x minus 2 equals plus or minus radical 10. All right, can you break 10 down? I don't think so, but all I can do is not make sure I understand I have two equations. I have x minus 2 equals radical 10, and I have x minus 2 equals negative radical 10. Remember, plus or minus gets you two answers. So I can't break that down. I'm just going to solve. I'm going to say x equals radical 10 plus 2. And I just can't add those together because they're not like terms. Here I get negative radical 10 plus 2. Now watch this. I want you to grab your calculator and type those in. I'm typing in radical 10 and then outside of that plus 2. I get x equals 5.16 to the nearest hundredth. Type the same thing in, the negative radical 10 plus 2, and I get x equals negative 1.16 to the nearest hundredth. Do either of those look familiar? Look at that example we just did. Those are the exact same numbers we got when we did it with the calculator. All right, so all of this stuff we've been doing is really the same thing over and over. When we complete the square, we are finding the zeros or the roots when we solve for x. Well, we're almost there, guys. Stick with me just a few more minutes. All right, example 5 here. Solve each of the following prime quadratic equations by first completing the square on the quadratic. Express your answer in simplest radical form. All right, so we've completed the square. It feels like a million times this year, and we're going to change one step in it. All right, so I'm going to work through the first one with you, and you've got the second one on your own. So really get this first one down, pause it, rewind it, do what you need to do. All right, so here we go. I've got x squared minus 10x. Now remember, when you complete the square, you're going to add a number, subtract a number, and keep that 23. Okay, it's got to go in that order. Now completing the square says we take the b term, all right, that middle term, that negative 10, we cut it in half. So if I cut negative 10 in half, I get negative 5, and then we wrap it up and square it. So I should be getting 25. And that's the number I'm going to add, and that's the number I'm going to subtract. All right, that's not the new part. That should be exactly what we're pretty darn good at. And then I'm going to take these three terms, and I'm going to rewrite them as a perfect square. X minus 5 times x minus 5. I'm going to take these two terms and add them together. Negative 25 plus 23 is negative 2. All right, so I can say this is x minus 5 squared minus 2. Now here's where the new part comes in. All right, so up to that, that's the old stuff. Now we're actually going to solve for x. All right, so this is the new stuff. We're going to solve this equation for x. So the first thing I'm going to do is isolate this, and I'm going to add that 2 over to the other side. Okay. Now it's just like the 3 previous problems we did. How do I get rid of that square? Well, I take the square root. Don't forget the plus minus. Those cancel, and I get x minus 5 equals plus or minus radical 2. The only question I have to ask myself is, can I break 2 down, or is it prime? So 2 can't be broken down, so the only thing I can do now is move this 5 over to the other side. And just remember, okay, as I move that over, I can't break up these terms here. They are married together. So I get positive 5 plus or minus radical 2. All right, so let me say that again. This 5 cannot come and invade this plus minus radical 2. Those have to stick together. Well, like I said, if I lost you at any point, pause it and rewind it, because what you've got next is problem B here. All right, and we're going to count this as a little quiz grade in your notebook, so take your time with it. Okay, it's right here, and we're looking for this to be completed the exact same way. So if you need to go rewatch problem A, pause it for 2 minutes, rewind it, and you're going to do the same thing. Good luck, and we'll see you tomorrow.